start out with just an overview of the presentation. We're going to start with what is rapid prototyping, advantages and disadvantages of the processes in general, some applications where you might use some of these. Also, we're going to spend most of the time on the various different methods and materials that are available in different processes, because there's a lot of different flavors under the heading of rapid prototyping. And I'm also going to show a case study of where rapid prototyping was used in an industrial setting, and talk a little bit about the future direction of rapid prototyping. What is rapid prototyping? It's a category of manufacturing processes that are additive processes. Instead of subtracting material, like when you're machining, you start with a solid block of material and you cut away the things that don't look like what you want. In this case, you lay down layer by layer and you put material where you do want it. There's many different varieties available, and some people call them all 3D printing. There's a lot of controversy over exactly what is 3D printing and what is not, and what's more properly termed other things. It's a new and developing field. One thing they all have in common is that they are driven by a 3D CAD file, which details exactly what the geometry is going to be. So you build it in a program like Pro Engineer or SolidWorks or Google SketchUp even, and usually it gets saved as a STL format file. It's generally the universal format that most of these machines work off of. Start with the advantages of rapid prototyping. Number one, there's no fixtures or tooling required. Once you have the machine, that's it. You don't have to build a new tool to make a new product. Like with injection molding, you want to make a new widget, you got to cut a new tool, and that'll cost you $6,000 or $10,000. This leads to much shorter setup times, lower setup costs, and it lets you do many different iterations on a design very quickly. Or you can have one base design and then you can make each one custom and do a little bit different each time. Again, no additional tooling costs. Also, the time to build is usually pretty quick for a first article. Under 24 hours once you've got the model set. Usually it's much shorter, especially if you're dealing with smaller pieces. Also, it's very eco-friendly. There's generally very, very little waste material involved with this, because you lay down the material you want and just leave the rest alone. There are certain designs that you can make that you can't make with any other known methods. For example, here I have something from Shapeways, which is a company that does rapid prototyping online. You send them your files and they mail you your product. And this is a cube of cubes. And this is all made, rapid prototyped in one piece. And you can see they're all interlinked. There's no joints. It's all one solid piece, and yet it's many pieces at the same time. Also, this is one thing that I made. It's a shave stand that I made because I wanted one. And you probably couldn't injection mold or machine this if you wanted to, because of some of the undercuts and angles. You'd have to make it in several different pieces. This is one solid piece. Talk about some disadvantages. When you want to make, say, 10,000 copies of the same thing, rapid prototyping is probably not for you. Then you want to do something like injection molding or sheet metal, or there's a whole bunch of other processes that we're not going to get into today that are much more efficient at making the exact same thing many, many times over. Also, for rapid prototyping, the per piece cost can be very high because some of the base materials are expensive and they usually charge by the cubic centimeter or by the liter or whatever, and it's a controlled market basically. When you get the more sophisticated machines especially, you have to buy like a cartridge, like HP printer cartridges, except this is bigger and more expensive, and they are the only ones who sell it. Most of the models also have relatively poor surface quality. It's not very smooth. And that's owed largely to the fact that it's all made in layers, as you'll see when I go into more detail on the specific processes. Also, because of that layering, most models are not quite as strong as if you had, say, an injection molded part. Often it's good enough for your testing, sometimes not. Also, it's usually much more brittle than the same resin if it was molded. You also have a limitation of only certain materials can be 3D printed, rapid prototypes, what have you. And if you want to do like some special engineering plastic or something, you're probably going to have a lot of difficulty finding a rapid prototype machine that uses that specific resin. So we have a question?
What about tolerances?
That varies with the different process, the different manufacturer, and basically each time you want to use a different process, you got to ask the manufacturer what can you hold. And I'll go into some detail of some of these are known for being very precise and some are not so much.
Harry?
Yes?
Are there multiple sources of materials? I mean, if you have a machine, can you use multiple?
It all depends on the specific machine, and that's a little bit beyond the level of detail that I can afford to go into right now, because you can see there's quite a few machines we're going to talk about.
How about the need for scaffolding?
That's also
Okay.
coming up. All right. Applications. What we have here on the top, that is an architectural scale model of a sports stadium. I'm told that the original is about 3 feet by 5 feet and is made of more than 40 separate parts. But if you want to build something exactly like that, you can literally take the architectural CAD model and shrink it down and 3D print it and show people exactly what it's going to look like to scale. One very common reason you would use rapid prototyping, hence the name, is for making prototypes, especially for if you're making injection molded products. So let's say I have something that's supposed to fit in my hand, and I've designed it in CAD, but I don't really know when I wrap my hand around it, is this going to be just right? So I can rapid prototype, I can 3D print a one-to-one scale model and actually hold it in my hand and see how it fits. Or I can take my circuit board and physically put it in there and make sure that it's going to fit and everything like that. Also, some of the newer and more interesting methods available are starting to make medical implants that are custom made to fit the patient. So some woman is walking around with a titanium jaw that was 3D printed to match the way her old jaw used to be.
Question.
Yes?
Do multi-colors?
We'll get to that.
Okay.
I'm going to ask people to hold up their questions till later, because I'm getting a lot of those. I'll get to it later questions. You can also use a FDM model, let's say here, for sand casting. In this case, I have a sample here. There's a company called MagnaFlood in Amityville, and this is a FDM model. I'll explain what that means in just a second. And this was 3D printed out of ABS, I believe. And they use that as a pattern for sand casting, and they make this one out of aluminum. And they make hundreds and hundreds by that method. Also, the final one here is rapid manufacturing. Now, this is where instead of using it just for a prototype, you 3D print something, and that thing is your product. Like, for example, the razor stand. This is one single 3D printed part, and this is for sale on Shapeways. You can go and order it and buy it, and it's one piece. Okay, fused deposition modeling, FDM. This is mostly used for plastics, especially ABS plastic is by far the most common for FDM. And you get the raw material in it looks like a spool of wire, except it's plastic. And the wire goes into the machine where it gets melted down and extruded in a very thin bead. It starts off on a platform, and that platform will drop with each successive layer, and the head goes back and traces the next one. Now, if you have overhanging details like you see in that image over there where you've got the hook over, you need to have support material below that, which is a different plastic that's made to be easy to remove. As the technology is getting better and better, the need for support material is being reduced. This, for example, was made specifically to showcase what they can make without using any support material. It was 3D printed with this as the base and going up with all that twisting and everything. So it definitely varies from machine to machine. Also, someone has demonstrated an FDM machine that makes pieces out of chocolate. That one is not quite available for people to purchase yet. There are several at-home kits that are available on the internet where you can build your own tabletop FDM machine. These range in level of specificity. Some just have the electronics, some have the electronics and the servo motors and things. You can even buy a kit where it'll ship like an IKEA box and you have to build the whole thing yourself and it has all the parts. Or you can even buy, there's one guy who's out there selling for $500 the whole thing. You buy it, you set it on your desk and you can run with it, which is a real breakthrough and has only come out kind of recently. Some people have also used FDM machines to build other FDM machines. You still need new electronics, you still need lead screws and things like that that you can't make with tight enough tolerances on an FDM machine, but it's just the sort of hacker coolness factor of I used a machine to make another machine and I can use that to make more machines. Okay, now we're getting into what I consider proper 3D printing, which works much like an inkjet printer. It starts out with a platform and you spread a layer of powder, often plaster, on that platform, and then you send the printer head over it and you squirt glue down where you want to keep the material and don't squirt glue down where you don't want the material. And then the stage lowers, spread another layer of powder and put the glue on and wash, lather, rinse, repeat basically. This one can allow you to use multiple colors of glue in the same printing, and that is an example of a Minecraft avatar. Minecraft is a computer game that a lot of people play that uses very blocky shapes, and there's a fellow on Shapeways who will take your avatar and give you a 3D printed version of it that looks just like that. And this is a physical sample here. This is Nyan Cat. It's an internet meme. I don't really understand it either, but it shows you just what the process can do. And in this type of application, the unglued powder works as a support material, so you don't need to put in support material per se. Also noteworthy is that this is a pretty low strength process in general because it's plaster powder and glue. It's usually used when your model is something that is visual only, or if you have to have multiple colors. Like sometimes biochemists will make models of proteins in full color to show what's carbon, what's oxygen, etc. And so you can pick it up and turn it around and see what the molecule actually looks like. It's typically a pretty fast process compared to other rapid prototyping methods and relatively low cost. Now we have selective laser sintering. It works mostly the same as 3D printing with layers of powder on a stage, and the stage goes down, another layer of powder, except instead of using a print head with glue, it will use a laser to melt the powder and fuse it to its neighbors. This is almost exclusively used with thermoplastic materials. And again, it's self-supporting because there's a layer of powder around it, and that powder that is used for support also, when you're done, you run it through a sifting process and you can generally reuse most of the powder. Also, we have candy fab. Instead of using a laser and thermoplastics, you use hot air and sugar, and you can make candy. this is another thing that is relatively new and not why this cool kind of concept. Now, if you want to use absolute top-notch, highest quality, full density, full strength, they use this for making prototype turbine blades for jet engines, and we're going to put this in the engine and test it out. Or the aforementioned medical jawbone replacement. As I said, it's very, very expensive. I don't have samples of that here. Now, there's another alternative if you have to have a metal product. It's metal 3D printing. I only know of one place commercially that is making that available, which is the Shapeways. And it's much less expensive than direct metal laser sintering, but it's not as strong. The surface quality is not very good. The dimensional accuracy is not as good. And it's made from a stainless steel powder, which is printed with an organic binder, sintered in an oven, and then infused with bronze. So it's actually a sort of bimetallic composite. And I actually have a video to demonstrate how it works. And you see this is basically the same thing as 3D printing, and then it goes into an oven. And that sort of gets it burns away the organic binder, and it gets the stainless steel to fuse to its neighbors a little bit, but not quite as, it's not full strength yet. And but anyhow, the rest of that video is basically that once you have removed the leftover stainless steel powder and taken the part out of that, it is then packed in bronze and then put into another oven at a higher temperature, and the bronze sort of infiltrates into the stainless steel and sort of locks it down and makes it much stronger. I have to say that's the most abrupt shutdown I've ever seen this computer do.
Must have been that virus they said was going to hit everybody.
No, I checked. I don't have that one.
Well, I think you would have been dead if you did.
Waiting for Windows reboot. Anyhow, to give you an idea of what that looks like, we'll have a bit of a shameless plug. I have a side business that is making wax seals and signet rings in a wide variety of symbols. And I can either give you the mushroom style here for any of these symbols, or I can make it as a ring. And they also, because it's 3D printed, I can do custom designs very easily compared to most other places where you would get signet rings where they would have to cast them and make a mold, and it's much more involved. There we go. And that's some examples of custom rings that I've made for previous clients. Another possible method of 3D printing is lost wax casting, and this is mostly used for sterling silver or gold, and the part is 3D printed in wax, much like you saw in other processes. The wax is then coated in a liquid plaster left to harden. Then that assembly is heated so that the wax burns off or melts out, and then the leftover plaster is used as a mold. They pour molten silver or gold in there, and you get, usually jewelry is what it's primarily used for. It can give you very fine detail. It's also very expensive because it's a very labor intensive process with a lot of manual involvement, and your material is usually precious metals. There's also glass 3D printing available. Now, I was not able to acquire a sample of this, and it's actually pretty difficult to find places that'll do this. The only one I know of is, again, Shapeways. The material is porous, it's not transparent, the surface is pretty rough, so it's not like a pane of glass, it's not crystal or anything like that. It's more like a pebbled glass looking. The the process is very similar to the metal 3D printing that we already saw. It's very weak, brittle, it's glass, and it's even more fragile than regular glass, and it's almost exclusively used for cosmetic purposes. We also have a video for this one. And you can see some of the areas where it's sprayed down the adhesive and some places where it hasn't. I believe this curing is more setting the binder material than anything else instead of burning it off. It's especially difficult and labor intensive because the parts are extremely fragile at this point. And it's kind of an inert support material that they use for when they're firing it, so that it doesn't distort.
Is that a liquid or a powder?
It's a powder. And then when it comes out, it looks like that. And those are some examples of different crazy artsy shapes that people make. And like I said, it's almost exclusively for cosmetic purposes because I think that would look cool more than for any structural reason.
What is the composition of the powder?
It's glass.
Powder is glass?
It's recycled glass. And almost all of the powder that isn't turned into a part is recycled. It's one of the most efficient processes around. Okay. Next up, we're going to go to something that's a little more different. This is called laminated object manufacturing. It's much less common than a lot of the other methods they've demonstrated here. Most of the time they use paper, sometimes they use metal foil, but it's in a roll that goes from one side to the other, and it's got adhesive backing on one side. So as the table moves down layer by layer, it advances the roll to the next one. A heated roller activates the adhesive to stick the block down, and then a laser cuts up the perimeter of the part that you want and then hatches up all the areas that you don't want for it to be removed later. Because all that material is there, it is self-supporting and you have no overhang issues. This is a pretty wasteful process though, because all that hatched up material is basically garbage. It can't really be used again. Stereolithography. This one uses a liquid bath of resin, and the platform goes down layer by layer, and a ultraviolet laser selectively cures some parts of it and not others, much like the other processes. This also requires support structure, and there's only one material involved, so you gotta go back when you're finished and remove all of that support material very carefully, and that can make it very labor intensive if you've got a lot of overhangs in your model. You can get very high quality, very good surfaces, very smooth models out of this, but it is substantially more expensive than most of the other processes. And the selection is very, very limited. There's very specific STL resin. Now, PolyJet, this one is interesting. This one, instead of having a head that moves back and forth as it goes across, it just kind of does a sweep across and drops down sort of like a curtain of material. And they all can do a support material and a regular material. And some of the new machines will allow you to print two different materials plus the support material at the same time. And these materials can be different things, like there's some ABS-like materials There's some high temperature materials, some are transparent, some are elastomers, and some are medical grade. So you could wind up 3D printing a part that is part ABS and part elastomer in the same 3D printing. So you could model, say, something with a rubber over-molded grip or something like that, all in one batch. This is, the latest and greatest and most expensive of the machines. And I got some samples here from Red-Eye. Red-Eye RPM is a company that does a lot of 3D printing. This is from their sample kit. This is the elastomer material that they make, and it's very flexible, as you can see. And they also have some very fine detail. This is a dinosaur head with some very fine teeth and texturing on the skin and everything. You can come and take a closer look at that later. I don't have any of the two-component ones. Those are a little more difficult to get. And we also have a video from Red-Eye.
Excuse me, can you pass the samples between
I'd rather not pass them around. They're a little delicate. This is just showing the modeling phase, multiple pieces printed at the same time. And one thing I should note is that the way that Shapeways keeps their cost down is they'll print many, many different things at once. So you kind of get in line, and it might take 2 weeks to get your part, but your part is 3D printed at the same time as 50 other people's, so it saves them a lot of setup time. And this is the curtain, as I was referring to, going across. And each pass, there's a UV light that cures it immediately as soon as it hits the model, basically. It talks about easy cartridge replacement. Remember how I was talking about HP ink cartridges? Those are special proprietary things that you have to buy from them, and I'm sure they charge an arm and a leg, especially for their really nice resins like the one that you can use to make dental implants. You wouldn't want to use those for for permanent dental fixtures, but they'll give you like a temporary crown or something, 3D printed, and then they'll use that same model to make the permanent one that'll be cast somewhere else. Also, the support material for the Object 3D PolyJet process is water soluble, so there's no manual removal process. You just squirt some water on it. And here they're also showcasing the high surface quality and detail. Also now, you can get Glazed Ceramics 3D printed.
Octopus is coffee.
Yes, it is called the Octo Cup. And this was made primarily as a artistic challenge. A certain gentleman decided to make 30 coffee cups in 30 days in different permutations, and this was one of the things that he thought up. There's a ceramic powder that gets 3D printed with an organic binder, hardened in an oven. Excess powder gets cleaned off. It then gets glazed and then fired in a kiln, and it gives you very smooth surfaces, very high quality in terms of it's a very smooth surface. You can make a cup that you can drink out of, and it's dishwasher safe and everything. But if you want to try to work fine detail into it, a lot of that detail can get lost in the glazing process. Also have some samples of that. This is black or white that they can do, some simple little vases. A poster, which I believe this is a street map of a certain city. There's a man who makes a series of them. I don't know which city this one is. And this is a bust of Cory Doctorow. Why? I don't know, but it is.
Which process is that in?
This is the Glazed Ceramic 3D printing.
Oh, that's the name of it?
That's what Shapeways calls it. I haven't seen anybody else doing it. Okay. Also, advanced step. That was supposed to get rid of. Now we'll go to the case study of the expanding can roller. This is a patented product that I made many years ago. And the goal of this product is to be able to have a point of purchase display where you can take cans of shaving cream, you can load them in the front, and it rolls up like that, and you can put a dozen cans in here, first in, first out. But the really tricky part of this design is sometimes Gillette sells cans that have 33% more free and they're an inch taller. That wouldn't fit in here. So we wanted a design where you could do this. And now it's an inch wider. No tools, no muss, no fuss. Very easy to do. And then when that promotion is over, it collapses back down. Quick and easy. Now, this is all injection molded plastic, and as I mentioned before, cutting injection mold tooling is very expensive, and there's some very fine details inside of it. We have here the exploded view diagram of all the pieces that go into it, and a close-up of the detail for the expansion joint that's in there, which is what most of the patent is on. Now, the detail you can see in there is pretty picky, and we wanted to make sure that everything fits just right. But we didn't want to waste a lot of money on 3D printing the entire model as an STL. So what we did was we made just that small sample piece, and here it is. This is the actual sample that we made. It's fused deposition modeling, which is almost full strength ABS. And we basically proved that it could work. I'm not going to click it because this model is brittle and I don't want to break it, but it does in fact work. We tested it, and then we cut the injection mold tool using the exact same CAD file, so we knew everything was going to fit. Politics. Yeah, there's politics to this. There's a pretty active online community. People usually consider themselves makers. It's very open, very highly democratic. People are all about this being a second industrial revolution of democratizing production. They want everybody to have their own rapid prototyping machine and be able to make whatever they want. Very much about freedom and openness and sharing. There's a website called Thingiverse that will people post up their models and say, hey, anybody who wants to make a 3D printed this, go ahead, I don't care. There's a lot of open source software and hardware, like those homemade 3D printers that we saw before. Most of this is generally limited to the low resolution FDM, but it's always improving. Like that's how the candy printer and chocolate printer got started, was through that community. You also have the high-end, high-tech machines, which are still dominated by big corporations who are trying to keep everything very secretive and proprietary and want to make sure that you have to buy your special resins just from them. So there's kind of a big political gulf between the two and difference of opinion there. In terms of future progress in the technology, researchers are working towards 3D printing human organs from your own cells. And they've already successfully implanted humans with 3D printed bladders. Also the aforementioned 3D printed jawbone. There's also some that are theoretically saying that there's no reason we couldn't eventually 3D print photovoltaic panels or solar cells. This is still a very preliminary, theoretical. Nobody's actually succeeded in doing this yet. So now, if there's any questions, we can start to address them. We have a lot.
Particle size, approximately. Are these powdered materials? How large are they? How many molecules are in a particle?
I have no idea, and it really depends on the individual process. Different manufacturers will use different grades and different materials. It's all different. You really got to ask the manufacturer.
What about the do-it-yourself stuff? Where do they get the materials from?
That is generally a certain particular flavor of ABS, and there's a bunch of online resellers that will that will make it, and from what I understand, they're pretty mutually compatible, so there's actually price competition to keep those reasonable.
About making the housing for defibrillators or pacemakers, then putting the boards in, custom to each individual body, I guess the bodies are different.
Theoretically, I'm sure you could do those things with the biocompatible materials. I don't see why not.
Is there anybody doing any standards associated with this approach?
Well, the closest thing to a standard, I would think, is the STL file format that most of them use. It's been around for a while, and that's probably the most unifying thing of all these processes. Really, some of them are very different from each other, and each manufacturer has their own way of doing it. It's a very fast-growing, fast-developing field, and next week somebody could come out with something completely different that I haven't even heard about yet.
You want to begin dabbling in this casually? Is there modeling software available, not multi-$1,000?
Google SketchUp is available for free. It is not by any means an engineering grade software, but you can do enough with it that people make stuff on Google SketchUp and send it to Shapeways and get it printed.
Yes, it is partly, there are a number of free 3D software products out there. They're cheaper versions or they're free versions of somebody else's or whatever. I think I mentioned them a couple of years ago when I talked. And I don't know if they put an STL file out or not, how you can save them.
Almost any CAD software prints out to an STL. It's pretty universal.
Yeah, but but there are some free things. If you email me, I'll try and find a file. I don't know where the heck they are though. The other thing is you only talked about additive rather than subtractive.
Well, that's generally the scope of this presentation. I wasn't
there are
dealing with
things,
subtractive
like
manufacturing.
A dentist has a machine that will cut the outside of a crown, I guess.
Sure, that's a computer numerically controlled CNC milling machine, which is not what I was striving to talk about.
I realize what you're talking about.
Right? Yes, wondering all these, when you're building stuff, I assume it's gravity determines the plane, all the layers of a certain plane. I'm just wondering whether for strength, I think you'd want to have other non-parallel planes, whether can you use electromagnetic fields to compensate for that, or even is there a possibility of using low gravity eventually?
I have no idea. You'd have to talk to people who are making the machines and things like that. I've never heard of such a thing. And, as far as I know, so far they're all gravity driven, and some of them have a bar that comes across and presses or tamps down the powder or something like that to make sure that it's uniform. But I'm not aware of using magnets or something to hold the metal powder in place. I think that might do weird things with patterns and what have you.
Brookhaven Labs does that. They're the only ones that I know. Brookhaven Labs, the only one.
Okay, we have the gentleman in the back.
Yeah, you said that the resolution is limited usually. So when you're trying to see if something fits, how do you know that it's made for the right tolerance? You need to know if it's
You take out a caliper and you measure it before you put it together and make sure that it meets your spec.
Okay.
But you basically deal with the manufacturer and you ask them what spec they can hold, because you and I can have the same machine and run it at different speeds and layer thickness, different tolerances. So it's really difficult for me to just make broad generalizations like that.
I think you mentioned that the platform goes down, and the distance it goes down is the thickness of the layer.
Right.
And if you want finer, it takes longer, but you put more layers down.
Right.
But again, the fitness and the part I've had to file parts to make them fit.
Sure. Another thing that's worth noting is that usually these machines have an XY resolution for the, sort of looking down at it, and a Z resolution for the layer thickness. And those are sort of two different numbers. So you'll get different accuracy in the one direction compared to the other two directions. And sometimes you want to specially specify which direction you want to be up in your part. Yep.
There's over two observations. about much older technologies, but you brought them to light here. The repeated putting down of layers is very much like the coil method of fabricating pottery.
Okay.
This goes back many centuries.
It sounds exactly like FDM.
Yeah, exactly so. I couldn't help but notice the similarity. And the other was the lost wax process. That goes back to the Renaissance.
Oh, sure. But, except we're 3D printing the wax here, which is what
Well,
makes it.
Leonardo da Vinci tried to make a giant bronze horse with the lost wax process. It would have been the largest structure ever made that way, but the mold broke and he failed, much to his dismay.
Okay.
Has anybody tried to print a circuit board using, say, the layer of metal foil on something?
I'm sure there are people who have tried all kinds of things. I have not heard of a successful project in that vein yet.
Well, it should be pointed out that circuit board production is very similar in that you put down layers of material in the machine, a dielectric and then a metal layer etched out however you like. So the additive process is really more mechanical, and it's been laying around in the electrical world for many, many years.
Yeah, additive copper has been used for quite a few years. Back then, there was a plant in Riverhead that made additive boards.
And the fact that you can get a PC board in 2 days kind of obsoletes the purpose of fast prototyping.
Yeah, but if you want to fit on certain curved surfaces.
Okay.
Have
Gentleman in
you
the white
seen
shirt?
this being used in building the inserts for a plastic mold, injection mold? There's a lot of the, I mean, this looks like it's beautiful for, you know, you drill a hole and the thing you stick in it is the stuff with the buildup, you know, with the stainless steel or whatever you're using for the material.
I'm not sure I understand what you're
In
asking.
other words, rather than making the part, you're making the mold to make the part, and you're using the process to make the mold, the insert for the mold.
Theoretically, you could use like a DMLS, direct metal laser sintering, and make a metal mold and use that for injection molding. I'm not aware of anybody doing that because I'm pretty sure it would be prohibitively expensive compared to just machining it away like traditional methods. But we do have, like I mentioned before, you know, making patterns out of 3D printing and then using that for sand casting. That's already a known quantity.
Yeah, but I'm thinking of when I've been retired for 10 years, but I do remember cases where we had 64 cavity molds, okay? And if you could make the one piece that would give you that one station and make 63 others off that particular piece, I forget it.
Yeah, over there.
Could you elaborate a little bit on medical, like bladders? You know, you talked about the synthetic bladder was made with this method, human cells. How realistic it is?
I wasn't able to find an extensive amount of detail on that. A lot of it is in scientific papers that are behind a paywall and things like that. But from what I understand, they 3D printed using a person's own cells and implanted it, and the guy, you know, walked away.
Well, there was a novel to that effect that I just read a few weeks ago, in fact. I forgot the author. It's one of these writers, I think it was a doctor or was a doctor or something like that. I'm not sure.
My understanding of the bladders from a program I saw on PBS was that they build the framework and then the cells are implanted on the framework and they grow on it.
Okay.
And then the framework is either removed or becomes obsolete and they implant it.
Probably water soluble or something like that.
Yeah.
You showed a layer method cured by UV. That's two materials. You have the actual material plus the support material. How do you control where you're placing the two different materials?
There's two different nozzles that one shoots out one material, one shoots out another.
In, how, in sheets though?
As that ribbon passes across, there's one curtain spraying one material, one curtain spraying the other material, and a UV light behind it.
And how do you prevent that UV from curing everything that you're spraying across?
You want the UV to cure everything as soon as it hits so that it doesn't spread out.
Yeah, but how do you control where you're placing the material? You're laying down a sheet like this, how do you?
There are many nozzles across that curtain.
Across the
So
curtain.
it's a whole lot of dots, like an inkjet printer.
Okay.
At least that's my understanding of it. The gentleman in the back?
Yeah, I don't remember you mentioning SLA. Is there was a difference between SLS and SLA?
Well, SLA is stereolithography and SLS is selective laser sintering. So I talked about both of those processes separately. Anything else?
I'm
Yes?
still confused about the bladder. Because the bladder isn't like a jawbone that just has to be strong. A bladder is an organic thing that moves and does something. So unless you have stem cells in there, how does it know?
All I really know is that somebody's managed to 3D print a human bladder, and I'm not an expert in the medical branch of things. I use it for making things like this and things like this. That's my primary experience with 3D printing is things that I can pick up and hold in my hand. And I'm not a doctor. I am not a specialist in all the human implant stuff. As far as I'm concerned, that's newly out of the science fiction and into the science fact.
Maybe I could imagine like they have synthetic hearts. This bladder also has synthetic.
Hey, I'm sure that's in the goals somewhere down the line to use human stem cells or whatever and reprint your own heart without a donor. I'm sure there's somebody working on that, but not yet.
You sound like the Star Trek transporter putting somebody together. I think you're into the initial development phase.
Actually, this is more of the replicator from Star Trek, and there is a version of an FDM machine that somebody is calling the replicator. Jerry?
So you're saying that the lower layers are cured immediately and they're not compressed by the weight of the upper layers?
It all depends on the process. I assume you're talking about the PolyJet. As far as I know, it's cured immediately with the layer by layer, and once it's cured, it's a solid. It doesn't move, as far as I know. Or maybe it does, and they take that into account. All I know is that I've gotten PolyJet parts that have been spot on.
But it's not denser at the bottom and...
Not as far as I know. Gentleman in the back?
Parts before where the beginning was a tighter tolerance than so it doesn't.
Well, yes, the layer thickness has a variability, and as it gets thicker, that you would have tolerance stack in terms of if you have a 1 inch high part and a 2 inch high part, it might be 1 inch high plus minus 5 thousandths and 2 inches high plus minus 10 thousandths.
What's the cost range on most of these products?
It all depends, and a lot of that depends on do you have your own machine or are you farming it out to somebody else's machine, and how long are you willing to wait. If you want to go to Red Eye RPM, you can get, PolyJet parts basically overnight if you're lucky. If you want to go to Shapeways, you might wait 2 weeks to get your part, but Shapeways will cost you a whole lot less than Red Eye.
So what's roughly the price range behind Red Eye and Shape?
It all depends on the exact material that you choose, the exact geometry that you have, how big it is, how many you're ordering, all kinds of things like that.
For example, one of your wax rings or the shaving stand. How much would that have cost at Shapeways?
I think the material cost on this was about $40 for this much of the 3D printed They call this white, strong, and flexible on Shapeways. It's a nylon material.
Okay.
And I think the base material cost for the seals was something, I don't remember. I sell these for the stock symbols for $60 with after markup and everything.
Has anybody built a rapid prototyping machine that in process does its own evaluation and error correction for the tolerancing?
I'm not aware of such a thing. That may be a feature of the more advanced and exotic machines. That's not something I've heard of. All right, we have another one in the back.
Best tolerances that you know of, the best tolerances.
You know, I really can't say. I look it up every time I need to know because it changes every single time with every single process. You really gotta pick one and ask.
Most of what you described here, it sounds like you either go out and buy a machine or you go to somebody who has one machine. Are there any companies that have a business model where it's a very exotic process and rather than selling drills, they're selling holes? They won't give you the machine, but they'll be glad to make this hyper-accurate part.
Oh, certainly. That's exactly what people like Red Eye and Shapeways do. They have a whole fleet of these machines, and they basically you're hiring out time on their machine.
They're proprietary. They're proprietary to Red Eye machines.
Red Eye uses mostly PolyJet, if I remember correctly, but I think they have a range of other processes available. They're a pretty full service place and very fast, but also expensive.
I think what he means, they don't build their own machines.
Oh no, there's companies that make the machines, and then there's companies that buy those machines and run them and sell parts off of them. Although in some cases, I'm pretty sure, I think Objet might own Red Eye or something like that, or there might be a business relationship between them. I'm not 100% sure. My specialty is not in the business side.
If the machines are patented, who would own the rights to it? The proprietary, what he said, the proprietary rights to the machine, right?
Whoever built the machine, whoever owns the rights to the patent. But once you make a thing, you know, if you own the rights to it, you own the rights to it. And there's all kinds of political issues and questions over if I 3D print something, can I be a copyright violator by my 3D printing? So, you know, if somebody owned the copyright to Nyan Cat, would this be violating the copyright on that? I've seen 3D prints in full color of Mario Brothers with the you know, the green potted plants sticking up and the chopper thing coming out.
You mean piranha plants?
Yeah, whatever.
Are there devices that will scan an object? I think I've heard of them. That'll scan an object and create an STL drawing set that you can then replicate.
Those do also exist, and actually there was a Letterman, not Letterman, Jay Leno did a bit where he went to a facility that does exactly that, and they showed like a toy of a Naboo fighter from Star Wars, and they put this thing on the platform, scanned it, and then 3D printed it. So now does that become a copyright violation and all kinds of questions like that?
Is it a copyright violation to make one copy of something you own? Of a printed device?
Is that making a backup copy? You see, I'm an engineer, not a lawyer, so if you want to know these questions, you want to go to somebody like Jerry.
You can't just go and walk into the Staples and copy a book. So like St. Margaret's, somebody has a toy. You can't. You have the laser. I don't know if you've ever seen where you do 3D scanning. You sit in the booth, they scan your face, and they burn your face into a glass cube, you know, with laser.
Okay.
That's kind of scanning 3D.
Pick up Jerry's question.
But years ago, I know somebody had a machine that
Jerry?
would take it, actually control this track, take the machine away.
Mario Brothers protection, you make a 3D model out of it. It's a derivative work.
Okay, but people are still fighting and arguing about it. You'll find people who will take both sides on the internet. Trust me, you'll find that on every major issue. Yes?
Months ago, there was a 3D thing that was going around the internet, where I don't recall if they scanned it or how they did it, but the end result was like a wrench, and they showed the wrench was totally workable.
Oh, yep. Yeah, I've seen that too. I don't have a sample of that particular thing, but I definitely seen that where they 3D printed all the parts for an adjustable wrench. It's plastic, it's brittle, but it kind of just shows you could.
I have a question about that particular thing. I saw
Okay.
that done to a video or something, crescent wrench, and they scanned it and made it. And that thing surely doesn't just directly produce an STL file.
Well, the 3D scanner, I turns it into a point cloud, and I'm pretty sure it does export as an STL file.
Even if you 3D scan, there have to be surfaces that are hidden from the scanner. So
Oh, sure. There are always going to be issues like that, and from what I understand, even if you have one of those machines, you have to go in manually and clean up the file. It's not to the point yet where I can just throw this widget in there and make a copy. It's a little more complicated than that.
That's why I didn't understand, because they showed it moving.
I had unusual cheating in there, so.
Thank you.
You know, you just reminded me of something. There was a Buck Rogers story about a duplicator that would replicate anything, including a person, but the replica would only last for 8 hours.
Hey, I want to say, Jerry, this is one of the best organized presentations.
Larry, did you do all this just for this meeting?
Yep.
Excellent job. Excellent.